we were scientists that we were interested in understanding how cells communicate and signal inside the mechanisms, the pathways, what happens in there. And at that time, that was something very difficult to do. There were no good tools to do that. Often you have to use things like radioactive materials to be able to see things, and that was, of course, not a great method. I mean, when you handle radioactivity, you have to take precautions, expensive shields, lab coats, etc., etc., etc. So the idea came from a concept that was already a little bit in the literature, but was to make these antibodies that can detect any given protein when it is, let's say, phosphorylated, modified at a site, at an amino acid. And that often indicates a different state of activation of that protein. So let's say that there was a pathway that triggered a cascade of signals that activated the protein, and you are measuring that protein's phosphorylation. You say, aha, this is activated. And there was a big gap, a big need in the field to be able to do that in a much more friendly, scalable, high throughput, cheap way. And these antibodies essentially, these antibodies provided a breakthrough to be able to answer these questions. So the idea was to generate these antibodies in a very high quality and robust way, and making them available commercially at a very, at a price that scientists could afford. And that essentially opened a new field of study, a big field of study that enabled drug discovery, basic biology,